All right, today we're going to look at the binomial theorem and how to use that to expand binomial expressions. So first thing we're going to look at is raising binomials to different powers. So if we look at x plus 1 to the 0 power, hopefully everyone realizes that anything to the 0 power is 1. If I raise x plus 1 to the first power, I get x plus 1. If I square x plus 1, I get x squared plus 2x plus 1. If I cube it, x cubed plus 3x squared, so 3x squared plus 3x plus 1. If I raise it to the fourth power, I get x to the fourth plus 4x to the third plus 6x squared plus 4x plus 1. Now if we look at all the coefficients of all of these terms, starting with this first one, so we've got the 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. And I'm not sure if you're familiar with that pattern, but that pattern is Pascal's triangle, which those coefficients are coming from Pascal's triangle so that we can use that triangle to expand binomials. So the next thing that we're going to look at is x plus y to the fifth power. So if you're looking at Pascal's triangle and you're doing the fifth power, you're going to go down to 6 because this is 0, 1, 2, 3, 4, 5, 6. So 0, 1, 2, 3, 4, 5. So I'm looking at this row right here, those coefficients. So I'm just going to put that right up here. So I'm going to have, there's going to be a 1 in front of there, but x to the fifth. The next number is, if you look at your Pascal's triangle, it's 5. Now your x to the fifth, that will now drop to x to the fourth, but then the y is now going to come into play. Plus, and if you look at the next number, that's 10. Again, x will drop to the third, y will rise to the second. Again, we have another 10, x squared, y to the third, plus 5x y to the fourth, and then just plus 5y to the fifth. So technically there is a y, and this first term is just y to the 0, because anything to the 0 power is 1, and over here there is an x, it's x to the 0. And again, as I went along here, I kind of mentioned what's happening with these exponents. Those exponents, the x's are decreasing as I move left to right, and the exponents of the y's are increasing. So now we're going to try 2x minus 3 to the fourth power. So if I'm looking at my Pascal's triangle, I'm at 0, 1, 2, 3, 4. I'm on that column there, or row there. Now, so you have to be kind of careful. So I'm going to have my 1, and then I'm going to have my 2x to the fourth power, my 3 to the 0 power, plus, then my coefficient is 4, so 4, my 2x to the third power, and then I have, this is negative 3, and then negative 3 to the first power, plus the next number is 6, so 2x squared, negative 3 squared, plus, I'm at 4 again, 4, 2x to the first, negative 3 to the third, plus coefficient of 1, 2x to the 0, negative 3 to the fourth. So then I need to simplify this. So I've got, this one's not going to affect anything. So I've got 2 to the 4th, which is 16, and then x to the 4th. So 16, x to the 4th, negative 3 to the 0 power is just 1. So then I've got this 4, and then I've got 2 to the 3rd, which is 8, and then x to the 3rd. Then I've got negative 3 to the 1st power, so negative 3. So I'm going to multiply all those coefficients, and I get negative 96 x to the 3rd. So here I've got my 6. 2x squared is 4x squared. Negative 3 squared is 9. I multiply that all out, and I get 216x squared. Coming over here, I have this 4. 2x to the 1st is just 2x. Negative 3 to the 3rd is negative 27. I multiply all that, and I get negative 216x. And then finally, I've got my 1. 2x to the 0 is 1. Negative 3 to the 4th is 81. So plus 81. This next one, x squared plus 2y to the 3rd. So now back to my Pascal's triangle. I'm at row 4. So 1, 2, 3, 4. So I'm looking at 1, 3, 3, 1. That's my coefficient. So I'm just going to put those here. 1, 3, 3, 1. So I'll start off with 1. X squared to the 3rd power, 2y to the 0, plus 3 times x squared squared, 2y to the 1st, plus 3 x squared to the 1st, 2y squared, and then 1 x squared to the 0, 2y to the 3rd. I'll give you guys a second to multiply that out. All right, when I do a power to a power rule, the rule is the base stays the same and I multiply the exponents. So this is 1 times x to the 6th. This is 1, so just x to the 6th. X squared squared is x to the 4th. So I've got 3x to the 4th times 2y would be 6x to the 4th y. I've got 3 times x squared to the 1st, which is just 3x squared, and then 2y squared would be 4y squared. So 3 times 4 is 12 x squared y squared. And then finally I've got 1 times 1, 2y to the 3rd would be 8y to the 3rd, so plus 8y to the 3rd. Now on x plus 3 to the 18th power, we're not going to do this because what will be the problem here? Well, if I look at my triangle, I don't have 19 rows. Yes, I could continue this to get down to the 19th row, but I'm not going to do that. So there's a way to do this without using Pascal's triangle, and that's going to be using combinations. And this symbol represents combinations. Another way to write that is n choose r. N choose r. And so how you do this, it's n factorial divided by r factorial times the difference of those two numbers factorial. And we can do this on our calculator, thank goodness. So let me show you how to do that. So I'm going to show you 2 different ways depending on the calculator that you have. So if I do 8 choose 2, if you have the newer calculator, let me grab that. I think it's pretty much the same thing on both of them. Let me just double check. So if I go to math and I go over to probability, you can see this n choose r. So I can go down there and then I can actually type in those numbers. So I would take it, type in an 8, and then a 2, and then enter. So that's 28. Now on the older calculators, you're going to go to the same place, but the problem is you have to put the 8 in first. So you'll go 8, and then you'll go over to math, again probability, you'll go down to number 3, then you type in what you're choosing 2, and then you're entering, so 28. So either calculator that you have, you can do this operation. So that takes us to the binomial theorem. If you're taking a binomial, let's say for example a plus b to the nth power, this is the pattern. You're going to do n choose 0, and then you'll have a to the nth, b to the 0, kind of just the way we did before. Then we do n choose 1. This choosing is giving me those coefficients that were in from Pascal's triangle. Again, my power of a decreases as I move left to right, and my b starts to increase. So then I have n choose 2, a to the n minus 2, b squared, plus, and so on, and so on, and so on. So let's try this using combinations. So I'm raising it to the 3rd power, so I'm going to do 3 choose 0. I'm going to do x to the 3rd, 1 to the 0, plus 3 choose 1, x squared, 1 to the 1st, plus 3 choose 2, x to the 1st, 1 squared, and then 3 choose 3, x to the 0, 1 to the 3rd. So then, like I said, you're going to go to your calculator and do the choosing. So you go to, again, math, over to probability, number 3. I'm going to choose 3, choose 0. And that's going to give me my 1, which is that if you look at this 4th row of Pascal's triangle, those are the numbers I should get for those 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3. So I get 1 times x to the 3rd, and then again 1, 0. If I do 3 choose 1, I could just go back up here and then edit. I could choose 1, enter, that's my 3. X squared 1 plus, again, just go back up here, copy that, go over, choose 2. That's going to give me my 3 again. And then finally, 3 choose 3. You can imagine will be 1. X to the 0 is 1, and 1 to the 3rd is 1. So then, just simplifying, I have x to the 3rd plus 3x squared plus 3x plus 1. Now we're going to try this one. So if we're looking at this formula, your little a is 3x and your b is -2 in your formula up here. So I'm going to do 4 choose 0. So it's really up to you. You can use this or you can use Pascal's triangle, either way. And then you're going to do 3x to the 4th, -2 to the 0, plus 4 choose 1, 3x to the 3rd, -2 to the 1st, 4 choose 2, 3x squared, -2 squared, plus 4 choose 3, 3x to the 1st, -2 cubed, and I'm running out of room, 4 choose 4, 3x to the 0, -2 to the 4th. In your calculator, 4 choose 0 is 1, So I've got 1. I'm going to do this. So there's 1. 3 to the 4th in your calculator. If you do 3 to the 4th, that's 81. X to the 4th, and then negative 2 to the 0 is 1. 4 choose 1 is 4. 3 to the 3rd power is 27. X to the 3rd times negative 2 plus 4 choose 2. If you do that in your calculator, you'll get 6. 3x squared is 9x squared. Negative 2 squared is 4. Plus 4 choose 3 is 4. 3x to the 1st is 3x. Negative 2 to the 3rd is negative 8. Plus 4 choose 4 is 1. 3 to the 4th, 3x to the 0 power is 1. And negative 2 to the 4th is 16. So then simplifying further, 84 x to the 4th. So I've got 4 times 27 times a negative 2, negative 216 x to the 3rd plus 6 times 9 times 4 is again 216 x squared, and then 4 times 3 times a negative 8 is negative 96 x, and then finally plus 16. All right, the last thing we're going to look at is finding a particular term within an expansion. And this will show up on an ACT occasionally as a question. It'll say, like, for example, what is the 7th term of 4x minus y squared to the 9th power? Well, instead of going and expanding it to the 9th power and then counting over to the 7th term and say blah, 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 you can use a formula. And so here is the formula. You're going to do the power of the original, so we'll call that n. Choose one less than the term you're looking for. So in this case, so I'm going to show you this would be, so I'm choosing 9. That 9 is coming from here. One less from that would be 6. So 7 minus 1. And then you're going to do your a, which is 4x. And that power will be the difference of those numbers. So 9 minus 6 would be to the 3rd power. And then you're going to do your b, which is negative y squared, and that's going to be raised to whatever this number is here. So 6. That's coming from there. I know it's a little confusing. So let's do 9 choose 6 in our calculator. So back to math. Number 3, so 9 choose 6, that's 84. So I have 84 times, then I'm going to do 4 to the 3rd power, that's 64, x to the 3rd, and then I've got negative y squared to the 6th power. Well, raising a negative to an even power makes it positive. And then remember, my rule is power to a power I multiply. So finally, I'm going to do 84 times 64, 5,376, x to the 3rd, y to the 12th. So on this one, I want to know what the 4th term is when I take x minus 3 and raise it to the 8th power. So again, I do 8, choose one less than the term I'm trying to find. So 1 less than 4 is 3. My a, which is x, my b, which is negative 3. So it's going to be my a to the difference of these numbers. So 8 minus 3 is 5. And my b will be to this bottom number, power. So again, math over to probability, number 3. I'm going to do 8, choose 3. That's 56. X to the fifth is just x to the fifth. Negative 3 to the third is negative 27. So 56 times negative 27 is negative 1512, negative 1512 x to the fifth. All right, I'm going to give you a second or two to work on this last one, and then we'll see if you agree with what I get. All right, really quickly, my a is y squared, my b is 2. So I'm going to do 10, choose one less than the term I'm finding, which is 5. I will take my a, and I'm going to raise it to the difference of those, which is 5. My b to the bottom, 10, choose 5. Choose 5. 252. Y squared to the fifth power would be y to the 10th. Power to a power we multiply. 2 to the fifth is 32. 252 times 32 is 8,064 y to the 10th. So that would be the sixth term when you take y squared plus 2 and raise it to the 10th power. So that's it for binomial expansion, and I'll see you guys on Wednesday.